Greetings, Mr. Sutton here, giving you the Pre-Cal Honors 2-5 Part 1 homework solutions on graphing polynomials in standard form. If we want to graph this polynomial, we have to factor it first in order to get the roots. So it looks like I can take at least an x squared out of everything because that's our lowest exponent. But also, if you look at the coefficients, we can take a 3 out of all these. So 3x squared then, and that's going to leave us with x squared minus 6x plus, this will be 8. I can factor this quadratic in parentheses a little bit more. I need factors of 8 that multiplied, or add up rather, to negative 6. So 1 and 8 won't do it, but 2 and 4 would, negative 2 and negative 4. So let me rewrite my 3x squared so I don't lose that. And then I've got x minus 2 and x minus 4. Setting each factor equal to 0 and solving for the roots. 3x squared, that's going to give us 0 for x. And then this next factor gives us positive 2, followed by positive 4. Putting those on our graph, we have the origin. Then 2 is a little bit to the right of that, and 4 is even more right than that. All right, for the end behavior, well, not the end behavior. Let's do y-intercept first. Let's at least address that. So if you plug 0 in for all the x's, that gives you a y-intercept of 0. And also, we already graphed the origin here, which is on the y-axis as well as the x-axis. So that is our y-intercept. No new points to put on the graph for that one. Now for the end behavior, that comes from this lead term of 3x to the 4th. That's a positive x to an even power. So this is going to behave like an x squared, like a parabola that opens up. And for the root behavior, it looks like it's 0. That's coming from this 3x squared. That's a double root, so we're going to bounce off of 0. And the 2 and the 4, those came from single power factors, so we're going to cross through those single roots there. So putting it all together, for our end behavior, we're going to start above the x-axis and end above the x-axis as well. So we go through 0, we bounce off of 0. There it is. And then come up, come back down, cross through 2. We have to cross through 4. And we end above the x-axis, just like our end behavior predicted we would. For this problem, we have to first get the roots in order to graph this. So that means we have to try factoring this. So let's see here. There's no common factors that are going to come out of this. However, there's 4 terms, so I could try factoring by grouping. For the first 2 terms, I can take out an x squared, leaving me with an x minus 9 inside. For the last 2 terms, I can take out a negative 9. That leaves me with another x and also a minus 9 for that parentheses. Since I have these x minus 9 common factors, I can take out x minus 9 next, and that leaves me with x squared minus 9, which is kind of cute, as my other factor. But I can break down this x squared a little further. So this is really an a squared minus b squared situation. So I can split that up into an a plus b, a minus b. So basically take the square root of x squared and 9, put them in a plus and a minus parentheses. So we have the original x minus 9 that was already there. Can't break that up. But this one now we can split into x plus 3, x minus 3. Now that this is fully factored in intercept form, we can easily pick out the roots. So zeroing out each of my factors, I've got x equals 9, negative 3, and positive 3. Putting those on my graph, I've got negative 3 to the left of the y-axis, positive 3 to the right somewhere, and 9 is also over there but a little further out. For the y-intercept, that's going to be this constant of 81 that would be left over if you plugged 0 in for all the x's. So that's going to be up here somewhere. And now the end behavior, that's going to rely on this lead term of x cubed. So we see that we have a positive x to an odd power. So this is going to behave like y equals x, a line, a slanting up line. So we're going to start below the x-axis, and we're going to end above the x-axis. And now for the root behavior, all of these factors are single power, so these are all single roots, meaning we are going to cross through all of those roots. So now starting below the x-axis, we're going to cross through negative 3, go through the y-intercept, cross through positive 3, come back down and up and cross through 9. and we end above the x-axis like our end behavior said we should. To graph this polynomial in standard form, we need to factor it in order to find the roots and also figure out what's happening at the x-intercepts. So taking a look here, it looks like I can definitely take out an x cubed because these all have at least an x cubed in them. I can also take out, actually, it looks like a -5. So -5x cubed. I should always take out as much as I can in the beginning here. So if I take that out of the first term, that leaves me with just x squared. And now -30x to the fourth divided by -5x cubed, that's going to be positive 6x. And then finally, taking that out of -25x cubed, that's a positive 5. Looks like I can factor this quadratic down a little bit further. Factors of 5 that add up to 6, well, only one choice, 1 and 5, and that does it. So I can split this up into, let's see, we have the original thing we factored out along with an x plus 1 and an x plus 5. Now that we're totally factored, zeroing out each factor to get our roots, we have x equals 0 for that x cubed, -1 for the middle factor, and -5 for that last factor. So graphing those out, -5 is all the way back here somewhere. -1 is closer to the y-axis, totally not drawn to scale, but at least it's in the right relative location. And then we have 0 at the origin. The y-intercept is also going to be 0. There's an invisible plus 0 at the end here. If you plug 0 in for x, you just get 0 because everything has an x. And besides, the x-intercept at 0 is also a y-intercept because it's on the y-axis. So that's our y-intercept. Now for the end behavior, we look at that lead term of -5x to the fifth. In general, that is a negative x to an odd power. So this behaves like the graph of y equals -x in terms of being like a downward slanting line. So we're starting above the x-axis and ending below the x-axis. And now for the root behavior, we have, let's see, -5 and -1. Those are both single power factors, so we're going to cross through those. And at 0, that came from this x cubed. Since that's a triple root, that means we're actually going to flatten as we go through that one. So putting it all together, starting above the x-axis, we cross through -5, come down, come back up, and cross through -1. And now we're going to flatten through 0, and we're going to end below the x-axis, which is in line with what our end behavior said we were going to do. To graph this polynomial in standard form, let's start by factoring so we can get the roots. It looks like we can take a -4 out of all of these, and also an x squared, because that's our lowest exponent. So -4x squared. That leaves us with, let's see, positive x squared, and then this is going to be -6x. And then this last one, -36x squared divided by -4x squared, is just positive 9. So factoring a little bit further, I'll just keep this -4x squared around for now. But inside this quadratic can get broken down. I need factors of 9 that add up to -6. Well, 1 and 9 doesn't work, but if we have -3 and -3, that adds up to -6. So I have an x minus 3 times another x minus 3, which at this point I'll just write as x minus 3 quantity squared. Setting each of my factors equal to 0 and solving, this first factor gives me a root of 0 for the x, and then I have an x equals 3 root for that x minus 3. Putting those on my graph, I've got the origin, and also x equals 3 is somewhere to the right over here. Now for the y-intercept, we actually already graphed it because this x-intercept at 0 is also on the y-axis. But if you weren't sure, you could just plug in 0 for x, and you'll see that all of this gets zeroed out, leaving us with 0 for the y-intercept. Now for the end behavior, we look at this -4x to the fourth lead term. That's a -x to an even power, which means this is going to behave like a -x squared, like an upside down parabola, starting below the x-axis and ending below the x-axis. In between, looking at our individual factors for root behavior, These are both squared factors, so 0 and 3 are both double roots, which means we are going to bounce at both of those spots. So putting it all together, we start below the x-axis, and we bounce off of 0, come down, go back up, and then bounce again at 3, and we end below the x-axis, which is where we expected to end.